Section 6.1, right triangle trigonometry. Again, hopefully most of this will be reviewed. Just basic SOHCAHTOA. It says an angle. First off, an angle is a combination of two rays that share a common endpoint, which is called the vertex. Don't you wish everything could be this simple? You've got a ray here, two rays that share a common endpoint. It's called a vertex. It's coming up. Next up, it says the amount an angle opens is called, or is measured in degrees. A degree is 1/360th of a circle. So if you want to measure that out, there's 360 total degrees in a circle, so 1/360th of any circle is going to be a degree. Right angles measure 90 degrees. A right angle is indicated with a small square. So if you have a right angle, I think all of us hopefully know this. If you have a small square in the corner, this is a right angle, which is a 90-degree angle. An angle that's less than 90 is called an acute angle. An obtuse angle is an angle between 90 and 180 degrees. You can't just say an angle bigger than 90 because a 280-degree angle is not obtuse. Say between 90 and 180. This next part might be the only part you don't remember. Fractional parts of degrees can be expressed in minutes and seconds. A minute, which is one little tick, little apostrophe there. A minute is 1/60th of a degree. A second is 1/60th of a minute, which would be 1/360th of a degree. This form is often called DMS form or degree minute second form. Example 1 says write 28 degrees, 45 minutes, and 36 seconds in decimal form. Easy. Let me show you how to do it. 28 degrees. So pretty much all it's saying here, 28 degrees, 45 minutes, and 36 seconds. Is that right? Yeah. Close that. We want to write that as like 28 point some odd degrees. Okay, and that's all it is. 28 degrees, 45 minutes, 36 seconds. Precision machinery might measure angles in this form. All you got to do, 45, think of it like this. This is 28 degrees plus another 45/60th of a degree plus another 36 3/60th of a degree. So just change those to decimals, add them together, and there's your decimal form. As long as you know this is this is a 60th, 1 minute would be a 60th of a degree. 1 second would be 1/360th. Let me pull up my calculator and we'll work this. So you've got 28 plus, now we'll go ahead and put it in parentheses, 45 divided by 60 plus 36 divided by 360, enter, 28.85 degrees. Come in. Next problem, we're doing right the opposite. It says write 50.3625 degrees in degree minute second form. So 50.3625. Again, easy. You've got a total of 50 degrees plus some odd minutes and seconds. You've got a fractional part of a degree out here. You've got, this is 3,625 10,000ths, right? So all you've got to do is take that and multiply it by, you're going to multiply it by 60 once. That's going to tell you how many minutes, and then you're going to multiply your answer by 60 again. That's going to tell you how many seconds. So you take the decimal part, and it's that fractional part of 60, so 0.3625 times 60. That's going to tell you how many minutes, and then you have some left over, so you have 21 minutes, and then you take the 0.75. That's again, those leftovers are your seconds. You'll take the 0.75 and times it by 60, and that'll tell you how many seconds. 45. I'm sorry, I did. My bad. That's the problem. So what I'll do, I'll take this other one and change it back just to show you again. These are really easy. On this other one, you would have 28 total minutes, and then you got the .85 as leftover, so you do .85 times 60. That gives you the number of, ooh, I miss them. Let's try this one more time. Going back and fixing an error from before, go back to your, well, the notes that you don't have. That's not 1/360th of a degree. That's wrong. Because if this is a 60th and that's a 60th of that, that should be 1/3600 degrees. So let's go back and change that. Instead of 36/360, that should be 36/3600. Because this is a 60th of this is a 60th of this, so a 60 times 60 should be 3600 instead of 360. So let's go back and fix that. Glad we caught that. So the first problem should be 28 plus 45 divided by 60. I made that mistake on purpose. To show you that all of these could be checked by going back and working it the opposite way. 28.76, that sounds better. 28.76 degrees, so now let's see if that matches up with what it's supposed to be. So the .76, if we do .76 times 60, we get 45.6, so 45 minutes, and then we do the .6 times 60 again, we get 36. Any questions? Change which one? No, this one's right because I was going from there to there. I multiplied by 60 each time, so no, it was fine. Still have to what? Did I not ever do that?
Yeah, you did.
One mark is minute, 2 marks seconds. Next problem. Thank you very much. Now that we're past the hard stuff. It says all triangles have 3 sides. That's pretty easy. Or all right triangles have 3 sides that are labeled according to some reference angle. And you need to know according to, like, our angle here, theta. A lot of times we use the letter theta to measure angles. Most of the time, any Greek alphabet, alpha, beta, theta, gamma, delta, just different Greek letters we use to represent angles. The side opposite the right angle, of course, is your hypotenuse. You already know that. The side next to, that's not the hypotenuse, the side next to your angle. Adjacent means next to you, that's your adjacent side. The side that doesn't even touch the angle, it's completely opposite the angle, of course, is your opposite angle. So let me switch this around. What if we were talking about this angle up here? Hypotenuse would be the same, but instead of adjacent, this would now be opposite, and this would be adjacent. Makes sense. There are 6 ratio combinations that we will use this chapter based on the previous triangle. For any given angle, theta, if we're talking about this theta here, not the one that I made, for any given angle theta in a right triangle, the following are true. Sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. We remember this by SOHCAHTOA. Sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. It says the reciprocal identities are also true, and you do need to know which ones are reciprocals of which. The reciprocal of sine is cosecant. It's 1 over sine, that's what reciprocal is. But 1 divided by something, it just flips whatever you're dividing it by. Cosecant 1 over sine is, instead of opposite over hypotenuse, is hypotenuse over opposite. The reciprocal of secant is the reciprocal of secant is cosine, so it's the flip of cosine. And cotangent is the reciprocal of tangent, which is simply the flip of tangent. So sine, cosecant are reciprocals, cosine and secant are reciprocals, and tangent, cotangent. It's easy to remember tangent, cotangent. And I tell this every year, and nobody ever uses it. Nobody has any idea what I'm talking about. The way I remember it, COS and SEC look the same frontwards and backwards, except for one letter. COS, CES. Frontwards, backwards, they look kind of the same. Reciprocals. I don't know That's how I have to remember it. If you have some other method, because most people put sine and secant as reciprocals, but they're not. As soon as we finish, I'll go round these notes off for you. Example 3 says evaluate the 6 trig ratios for the angle theta in the figure below. Sine. Sine is opposite over hypotenuse, so if this is my angle here, opposite is, hypotenuse is, so 10 over 26, that's the same thing as 5 over 13. That's all you have to do. Cosine is adjacent over hypotenuse. What's adjacent? Over hypotenuse, which is 12/13. Tangent, opposite over adjacent. What's opposite? What's adjacent? So that would be 5 over 12. Cosine was 12 over 13. Instead of having to do those again, if you know which ones are reciprocals, cosecant is reciprocal of sine. Since sine is 5 over 13, cosecant is 13 over 5. The secant is a reciprocal of cosine, so it would be 13 over 12. And cotangent is the reciprocal of tangent, so it would be 12 over 5. Any questions? Let me show you that you can actually, it doesn't have to be a theta there, even if you have a number there. You can still do the same exact same thing. Evaluate the 6 trig functions of 50 degrees by using the triangle below. The sine of 50 degrees. Opposite over hypotenuse, 12.51 over 16.34. So therefore the cosecant of 50 degrees, erase that, would equal 16.34 over 12.51. And you could actually divide that out. I'm not going to go through all those. Y'all